Teacher Diane, and welcome to Easy Sci Tutorial. The most essential learning competency in this lesson is to describe the motion of an object in terms of speed, velocity, and acceleration. In this video lesson, you will answer how fast an object moves by describing speed, velocity, and acceleration. Come on, let's start learning.
Have you ever wondered why different objects travel the same distance, but they take different amount of time? This is because some objects are traveling faster or slower than others. Aside from finding out how far did the object travel, we can also describe motion by finding out how fast did the object move from its initial position to its final position. Also, we can describe the motion by finding how the object is moving with changing speed or velocity. Before we start discussing our lesson, let us try answering the learning task number 1. Read the text, then answer the following questions. Write your answers in your answer sheet. The cheetah, scientifically known as Acinonyx jubatus, is the fastest animal in the land. It can reach a speed between 112 and 120 kilometers per hour. From a standing start, a cheetah can cover a distance of 460 meters or 1,500 feet in 3 seconds. Its fast speed is an advantage as predator. Answer the following questions. 1. What is the fastest animal inland? 2. How far does it cover for 3 seconds? And 3. What is the advantage of cheetah as predator? I will give you 15 seconds to answer those questions. Okay, time's up. Let us check. Number 1. What is the fastest animal inland? The answer is correct. Cheetah. Number 2. How far does it cover for 3 seconds? You got it right. 460 meters. And last, number 3. What is the advantage of cheetah as predator? Yes, it's fast speed.
Now, let us fully understand what is speed. Speed refers to the rate of distance covered at a given time. The equation that we will be using in solving the speed is speed is equals distance divided by time. The symbol for speed is S or V. The symbol for distance is D, while the symbol for time is T. Speed is a scalar quantity, meaning it has magnitude only, no direction. There are some common units of speed. We have meters per second, kilometers per hour, and miles per hour. Examples of speed. We have 40 km per hour, 2 meter per second, and 10 miles per hour.
In some examples, distance or time is not given. In this case, the following equation could help. Be sure to cancel the same unit to get the corresponding unit. This is the equation in solving the distance. Distance is equals to speed times time. Here are the common units of distance: meters, kilometers, and miles. Examples: 40 meters, 75 kilometers, 100 miles. While in solving the time, the equation that we will be using is time is equals to distance divided by speed. Here are some common units of time: second, minute, hour. Here are the examples: 5 seconds, 10 minutes, 20 hours. Remember this triangle in solving distance, time, and speed. When we are looking for distance, we need to multiply speed by time. When we are looking for time, we need to divide distance from speed. And lastly, when we are looking for speed, we need to divide distance by time. Now, are you ready to apply what you have learned and solve problems? Let's try. Sample problem. A runner sprints the 100-meter dash in 20 seconds. What is his speed? In order for us to properly answer the sample problem, we will be applying the so-called GRESA method. Or, we need to write the given, required, equation, solution, and answer.
Let us now answer the sample problem. First, write the given. We have distance is equals to 100 meter and time is equals to 20 seconds. Next, write the required. Required or what is being asked. And that is the speed. After writing the required, proceed in writing the equation. So the equation or the formula that we will be using in solving the speed is speed is equals to distance divided by time. Now, let us solve by substituting the given. Okay, speed is equals to, what is the value of distance? Okay, 100 meter. Divided by the value of time, which is 20 seconds. We just need to divide. And the answer is 100 meter divided by 20 seconds. Okay, the answer is 5 meter per second. That's it. We completed the GRESA. The given, required, equation, solution, and answer. Just keep in mind that an object moving with high speed covers a greater distance in a particular amount of time, while an object moving in low speed covers less distance in the same amount of time.
After learning all about speed, we will proceed to the next. Whenever there is a storm coming, we are notified of its impending danger in terms of its speed and direction. And we are referring to what we so called velocity.
Velocity is a speed in a given direction. Since velocity has direction, it uses displacement instead of distance. Velocity is a vector quantity, meaning it has magnitude and direction. Examples: 2 kilometer per hour east, 10 meter per second northeast, 4 miles per hour west. To solve the velocity, we will use the equation velocity is equals to displacement divided by time. Notice the symbols that represents the velocity, displacement, and time. Also, check out this triangle formula to guide us in solving problems.
Are you ready to solve another problem? Let's try. What is a cyclist's average velocity if he changes position from 10 meter east to 40 meter east during 5 seconds interval? Again, we will be using the Gressa method. You need to write the given, required, equation, solution, and answer.
Now, let us answer the sample problem. First, we need to write the given. We have the initial position, which is equals to 10 meter east. And for the final position, which is equals to 40 meter east. And the time of 5 seconds. Next, write the required. Required or what is being asked. And that is velocity. After writing the required, we need to write the equation. Or what is the formula that we will be using in solving the velocity. So we have velocity is equals to displacement divided by time. Let us have the solution. Velocity is equals to the value of displacement divided by the value of time. So in order for us to find the displacement, we need to subtract the value of the final position to the initial position. So 40 meter east minus 10 meter east divided by 5 seconds. So 40 meter east minus 10 meter east is equals to 30 meter east. Just copy the value of time, which is 5 seconds. And the final answer is 30 meter east divided by 5 seconds. That is 6 meter per second east.
Now that we are done in discussing all about velocity, we will proceed to the last part. Vehicles rarely move at constant speed, but oftentimes they change speed. Consider the figure below. This figure shows the acceleration of an object. The figure shows the speedometer's reading of a car at 1 second interval within 4 seconds. At time 0, the car is at rest. The car started to move at 1 second with a speed of 5 km per hour until at 4 seconds, the car speed is 50 km per hour.
The changing motion of an object is called acceleration. Acceleration refers to the rate of change in speed or velocity. And the equation that we will be using in solving the acceleration is acceleration is equals to change of velocity divided by time. And the symbol that we will be using in solving acceleration is A for acceleration, Vf for final velocity, Vi for initial velocity, and T for time. The common units of acceleration, we have meter per second squared and kilometer per hour squared.
When a moving body decreases its velocity, it is said to decelerate. This negative acceleration is called deceleration. Deceleration is the opposite of acceleration, where the velocity of an object decreases, just like in the animation, wherein the motorist is traveling from 185 km per hour, then slows down to 95 km per hour. Now, are you ready to solve another problem? Come on, let's do it. A fish swimming at a constant speed of zero point 0.5 meter per second suddenly notices a shark appear behind it. 5 seconds later, the fish is swimming in the same direction at a speed of 2.5 meter per second. Calculate the fish acceleration. Again, we will be using the Gressa method, which is given, required, equation, solution, and answer.
Let us answer the sample problem. Again, we need to write the given. We have the initial velocity, which is equals to 0.5 meter per second, and the final velocity, which is equals to 2.5 meter per second, and the value of time, which is 5 seconds. After writing the given, again, we need to write the required, or what is being asked, and that is acceleration. How are we going to solve the acceleration? So we need to write the equation, or the formula that we will be using, which is acceleration is equals to the final velocity minus initial velocity divided by time. For the solution, acceleration is equals to the final velocity, which is 2.5 meter per second, minus the initial velocity, which is 0.5 meter per second, divided by the value of time, which is 5 seconds. 2.5 meter per second minus 0.5 meter per second, the answer is 2 meter per second. Divided by, copy again the value of time, which is 5 seconds. So, 2 meter per second divided by 5 seconds, the answer is 0.4 meter per second squared. The acceleration of the fish is 0.4 meter per second squared, meaning it is a positive acceleration.
Just remember that if there is uniform motion in which the object travels, equal distance at equal time, the object is not accelerating because the speed and direction do not change. And if there is non-uniform motion in which the object travels an equal distance at an equal time, the object is accelerating because the speed and direction change. Let us answer the learning task number 2. Read each statement carefully. Determine if it is describing speed or velocity by writing the statement inside its corresponding classification. Write your answer in your answer sheet. Okay, time's up. Let us check. Number 1. Tropical storm traveling 88 km per hour eastward. It describing velocity. Correct. 2. Jacob ran 10 meters in 10 seconds. It is describing speed. Correct. Number 3. Jean moved the plate 50 centimeters to the right in 3 seconds. It is also velocity. Rafael swims 120 meters towards the shore in 60 seconds. It also describes velocity. And last, number 5, a ship cruising 34 miles per hour. It is describing speed. As you can see, when we are talking about speed, it has distance and time. And when we are talking about velocity, it has speed with direction. Who got a perfect score? Alright, congratulations. Next, let us answer the learning task 3. Solve me. Analyze and solve the problem below. Show your solution in your answer sheet. Again, you need to use the GRESA method. 1. A man walks 36 km in 4 hours. Find his speed. 2. What is a motorist's average velocity if he changes position from 50 meter east to 80 meter east during 12 seconds interval? And last, number 3, a racehorse coming out from the gate accelerates from rest to a speed of 15 meter per second in 3 seconds. What is its acceleration? Time's up. Let us check. Answer for number 1. Here are the given. Distance equals to 36 km. Time is equals to 4 hour. Required speed. Equation. Speed is equals to distance divided by time. In order for us to solve, we need to substitute the value of the given. So speed is equals to 36 km, which is the distance, divided by 4 hour, which is the time. So 36 km divided by 4 hour, the answer is 9 km per hour. And for the answer for number 2, we have the given. Initial position is equals to 50 meter east. Final position is equals to 80 meter east. And time is equals to 12 seconds. What is being asked or required? The velocity. And the equation that we will be using in finding the velocity is equals displacement divided by time. For the solution, velocity is equal to, we need to subtract the value of the final position to the initial position for us to determine what is the displacement. So 80 meter east minus 50 meter east is equals to 30 meter east. And the value of time is 12 seconds. So 30 meter east divided by 12 seconds, the answer is 2.5 meter per second is. And this is the answer for number 3. We have the given initial velocity is equals to 0, final velocity is equals to 15 meter per second, and time is equal to 3 seconds. Required acceleration. Equation. Acceleration is equals to final velocity minus initial velocity divided by time. And for the solution, acceleration is equal to, we need to subtract the value of the final velocity to the initial velocity. So 15 meter per second minus 0 divided by 3 seconds, which is the time. So 15 minus 0 is equals to 15 divided by 3. The final answer is 5 meter per second squared. And for the reflection, complete the following sentence prompts. I understand that. I realize that. I need to learn more about.